Hi, good morning and welcome to today's class. Today's class is our first class for the SS3 students. In today's class, we shall be looking at the topic surds. The objective of this topic includes 1. To differentiate between rational and irrational numbers. We shall learn what rational numbers are and irrational numbers and try to differentiate them. That will introduce us into surd. We shall also apply the rules of addition and subtraction of surds in solving surd problems. 3. We shall apply the rules of multiplication and division of surds in solving surds problems. And thereafter, we shall try to explain the concept of conjugate binomial surds. 5th, we shall apply the concept of surds to problems involving trigonometrical ratios of angles 30, 45, and 60 degrees. So that will be our objective at the end of today's course. But for today's class, we shall center on rational and irrational numbers leading to surds. Now, a rational number is a number that can be expressed as a ratio of two integers, a over b, where a is an integer and b is an integer. So any number that can be expressed as a ratio of two integers, a over b, such a number is said to be a rational number. Rational number includes examples of rational number. We have all numbers of the form a over b, where a and b are integers. So any number that can be expressed as a over b, we said such a number can be referred to as a rational number, so long as b is not equal to 0. If b is equal to 0, then such a number can be said to be undefined. Or when you use your calculator to punch, it gives you math or syntax error. 2, we said integers which are whole numbers which may be positive or negative are also said to be rational numbers. An example, we have -3, -2, -1, 0, 1, 2, and 3. All these are said to be rational numbers, and they can be denoted using letter Z, where Z subscript positive stands for the positive integers, and Z superscript negative, I beg your pardon, is also referred to as negative integers. Another type of rational numbers are said to be proper fractions. Proper fractions are numbers less than 1. We refer to them as rational numbers. So, example of proper fractions, we have 1 over 2, which is half, 3 over 4, which is 3/4, etc. And proper fractions are said to be fractions where the numerators is less than the denominator. 1 is the numerator, 3 is the numerator, 2 and 4 are said to be the denominators. 4. Improper fractions are numbers greater than 1. That is, the numerator is greater than the denominator. When you have a fraction of this form, 5 over 2, 7 over 3, 8 over 5, we refer to them as improper fractions. Reason being that the numerators are greater than the denominators, so they are referred to as improper fractions. Another example of a rational number includes mixed numbers. 5 over 2, which is an improper fraction, can be reduced or simplified to be 2.5. This is referred to as a mixed number, while 7 over 3 which can be simplified to be 2 whole number 1 over 3, is referred to as a mixed number. We also have 8 over 5, which is simplified to be 5 whole number 3 over 5. All these are examples of rational numbers. Also, powers and square roots may be rational numbers if their standard forms are rational numbers. We shall see more examples on that. And in rational numbers, the denominator cannot be 0. That I have already explained. An irrational number is a real number that cannot be expressed as a fraction, that is, as the ratio of 2 integers. Examples of irrational numbers include pi, which is expressed as 22 over 7. We have root 2, root 3, and root 7, etc. These are said to be irrational numbers. I'm going to explain to you why pi, which is approximately 22 over 7, is an irrational number. Just as decimals, irrational numbers cannot end. That is, they go on forever or till infinity. For example, if you have root 2, if you punch your calculator, you will discover that it gives you a number 1.4142135 and so on and so forth. It does not have a definite end. So we refer to such numbers that don't have a definite end as irrational numbers. Or although we have some rational numbers that don't have an end, but they have a recurring decimals, something like 10 over 3, okay, which gives you 1.3333. You discover that we have 3333, which is a recurring decimal. So such numbers are rational numbers. But for that, we do not have a recurring decimal. For example, in the case of this root 2, which is 1.414213, there is no end. You don't have a recurring decimal. So we refer to such numbers as irrational numbers. Then we have pi, which is an approximate value. An approximate value does not mean it is that value, okay? So 22 over 7, you may argue with me that that is equivalent to pi. Yes, it is equivalent, but it is not pi. Because even if you divide 22 over 7, pi is approximately 3.142, as we all know. But the actual value of pi is 3.141592665, and so on and so forth. But it is approximately 3.142. So pi is not a rational number. It is an irrational number. And irrational numbers are also denoted using Q bar. That brings us to the end of today's class. In today's class, we have been able to understand what we mean by rational and irrational number, as well as to show the differences between them. In our next class, we shall take the second objective, which says apply the rules of addition and subtraction of surds in solving surd problems. In our next class, we shall look at surds and carrying out operations on surd. Thank you for being a partaker in today's class. Please kindly like our videos, while we advise that you subscribe. Also, you can share to your friends and family so that they can also benefit from this project. Thank you very much, and see you in our next series. Bye.